Hello, good afternoon. Uh, we're working online today with cable fault location equipment demo, and let me introduce myself. My name is Dmitry Tumasov, and I'm technical engineer of Techno AC, Russia. And today we are demonstrating cable fault locators, but before that, I would like to check if you can hear me and see me well. As usual, we are having some technical testing part because we're doing the online demo. So if you can see me and hear me well, just send plus in chat so we knew that everything is clear and everything works fine. Meanwhile, I will explain what cable fault location equipment we have in our range. So you know that Techno AC has been manufacturing and developing the utility location equipment for almost 30 years. Next year we are going to celebrate 30 years anniversary of our company and of our business in general. And for this long period of time, we have developed many instruments and tools which were pretty competitive on Russian and international market. Of course, there is much more to improve in our equipment, and we constantly do this because the unique feature of our company is that we manufacture, we develop, and we use our equipment by ourselves. So when we are making new model of equipment, we also test it with our clients in real working conditions in the field. So today we are going to talk about cable fault locators. Among cable fault locators, beside cable fault locators, we have cable locators, water leak detectors, and cable and pipe locators. Every model of our equipment you can check at our website www.technoac.com. Also, the record of this particular event will be available on our YouTube channel. You can search for Techno AC EN, which stands for English, and you will see this record right after this event ends. Okay, I guess we have finished with introductory part, and now we will move to the equipment itself. So today we're going to use AP19.3 receiver. You may be familiar with this equipment. This is a utility location receiver, which literally indicates the cable or the pipe on the screen. Let me switch the frequencies just to demonstrate a little bit. Yeah, like this. You can see the line of the cable right on the screen. This is key feature of this device. Also, it supports depth measurement, and it has built-in GPS module, so you could acquire the GPS coordinates and store them in device memory and later upload them to your personal computer. So this is what we're gonna use today. Also, we will be using this sensor. It's quite big, and it is new basically. Most of you are familiar with the so-called Aframe sensor, and you can see that this particular sensor looks like the letter A. That is why it is called Aframe. And you know that usually we supply plastic extendable A-frame sensor, which is called DKI. You may be familiar with that. This one is new model, so I guess this is kind of a presentation. of a new sensor. It does the same job, but it is better for gas pipes and for cables, both for cables and pipes. And the main feature of this device is that it is made of metal. So this thing is completely metal, and it has longer. You can see longer contact rods with the limiters. So it is much more rugged sensor, which can sustain more more complicated conditions. This is what we're going to use today with AP 19.3 receiver. Also, we will be generating the signal inside the cable with AG105. This is quite portable transmitter. You may be familiar with it also. Nothing new here, same as usual, 20-watt power, direct connection, induction antenna built in inside the transmitter, multiple frequencies support, 512 hertz, 1 kilohertz, 8 kilohertz, and 33 kilohertz. Everything is in this little instrument. Powered by 8 baby C batteries or accumulators. It depends on your requirement. Also, for test purposes, we will be having our cable. This cable is a mobile test field for cable fault location and TDR test. You also may be familiar with this accessory. We used it on our previous cable fault location demo. So yeah, we have simulated several cable faults, and we have expanded the cable to our parking lot because there is still snow. The winter is still here, and it's not going away, although we're waiting. Yeah, and if we have time, and if the equipment, the camera allows us, I will also give you the demo of TDR 4.7 time domain reflectometer, which I'm having here. You're also familiar with this equipment, but speaking about cable fault location, I guess it is going to be right to tell you anything about this device also. So, yeah, this is our plan for today. So it's gonna take some time. So if you want, you can make some tea and take some cookies just to feel cozy out there. And we will start right at once. Okay, what do we have here? First of all, we have to create the signal inside the cable. This is the barrel with the cable, and it goes all the way uh, through our parking lot. Somewhere out there, we have simulated the leakage of the current to the ground. We're going to locate it, and I will show you how it's done with AP 19.3 and DKI or Aframe sensor. Uh, as there is snow and it is very soft, and I will show you only the part where we have the damage itself, so we could save our shoes and save a little bit of time. And first of all, I will be creating the signal inside the cable. So first thing you have to do to connect the transmitter to a cable is to apply the crocodile clamp to some leads of the cable. You can see that we have several conductors of the cable, and we have connected one of them to the conductor number 3, and another crocodile of the cable of the transmitter we have connected to the grounding. Let me check it, by the way. Yeah, it's fine. This is a grounding rod. We used hammer to push it deeper into the ground because the ground is still frozen, although it's +1 outside. And now we will create an electrical signal inside the cable, inside our test barrel, and we will see if we are able to locate it. Let's do this. We will turn on the transmitter by pressing on off button. Then we will switch the indication of the transmitter to frequency, and we will set 1 kilohertz frequency and press start. While transmitter is gaining its power, I will tell you that this is lowest effective frequency for DKI or A-frame usage. You can use it particularly on any frequency, but when using this sensor, I would recommend starting with this frequency. Okay, you can see that the transmitter has its full power, 40 volts. It is indicated on the screen. Okay, and we are moving to the sensor. You see, it's pretty big, and the method, the physics behind this is the following. These are two conductors, and the sensor and the receiver, they evaluate the difference of electric potential between these two conductors. I'm pretty sure that you are aware of how this technology works, because it's it is supplied with almost any cable and pipe locator. Techno AC locators are not exception. This sensor can be purchased with any locator by Techno AC. So the device is evaluating the difference in electric potential and evaluates the signal level. And this is how we will be able to tell if there is a cable fault or not. This particular sensor is used for two main applications. The first one is leakage of the current to the ground. What does that mean? It means that if an insulation of a cable is damaged and metal part of the cable is touching the ground, the earth, the current will be leaking through the ground surface somewhere. Yeah, and or it is called short circuit to the ground, so the current will be going to the ground, and this device is capable of locating it. Also, the same procedure happens with the pipe. If the pipe is insulated with rubber to protect it from corrosion, but somehow it gets damaged, the current also leaking to the ground. This device is capable of locating it. Also, if there is damage or leakage, there are some cases when these devices helped to locate these leakages with the same method, but I wouldn't recommend to do that. I would recommend to check the insulation condition. So basically, in Russian, this device is called insulation test sensor. So it was designed and it was developed to test the insulation of pipes and cables. So let us check if we can locate, and what we will see on the receiver when we locate the fault which we have simulated on our cable. Let's do this. So first of all, I'm taking it like this, and I will be connecting the sensor to the receiver. Let me do that. I will put it aside for a moment, just to show you one important thing. Also, I will take this away. Here on the receiver, you have the connection port for external sensors. Yeah, it's even marked like that. And also here you have a mini USB port for uploading the GPS data and GPS coordinates and depth and tracking and everything to your personal computer. It is protected with safety cap because water can damage this port if it's not properly closed. So let me do this. And when I'm connecting When I'm connecting the sensor, please look at the screen. Just hold on a second. I'm doing that. You can see that receiver automatically recognizes the sensor and enables the mode which is combined, the cable location mode and the graph mode, which will represent the signal level while we will be locating the fault. Let me do the following thing. I will switch the frequency of, okay, wrong button, okay. Let me check the frequency. Now it's 50 hertz. Let's switch it to 1 kilohertz. Confirm. And now the receiver and the sensor will be sensing what is happening only in our test cable, because the signal and test cable is the same, 1 kilohertz. So we have made all the settings we need. We take Aframe sensor, we take it with us, and we will go all the way to the supposed point of damage. But we will not go that way because the snow is too soft. We will go around. And we will go all the way here. And you can see that here we have simulated the fault. This is the box, the junction box with the fault. And this is the lead which simulates the leaking of the current to the ground. Yeah, it looks like we have located it, but we have to demonstrate how does this thing work when we use it in normal conditions, when you can't see the cable, when the cable is underground. So what we do here, we stick the sensor to the ground. I'm trying to be careful because cars of my colleagues are also there. As this thing made of metal, you can use your legs to stick it to the ground actually. And you can see that the receiver is indicating the cable which we are standing above. There's the cable. Yeah, there it is. Yeah. And the graph is representing the signal which we're getting from our sensors. And now you can see that the sensor is standing 1.5 meters from the fault, and it shows almost nothing, no signal. Let us move the sensor and we will see what indications we will have on the receiver when we move the sensor closer to the fault. I will use my leg again just to push it a little bit deeper. Yeah. Now you can see we have maximum signal here. Almost maximum. The receiver is almost overloaded. It means that we are approaching our fault. Literally, we are approaching it. So when you are working with DKI or A-frame sensor, you go all the way the cable, you tracing it, and then you start to approach the fault itself, and you will see the increase of the signal. And now I will be doing the following. I will push one sensor, one leg of the sensor to the spot of damage, supposed spot of damage, and another one just a little bit off the cable, but alongside the cable. And we can see that the signal is decreasing. We had 80 something, but we now have 49, 50. The signal is getting lower when we have approached the damage. Let's do the following. Stick the sensor right between the legs, right above the cable fault. Again, maximum signal. So when you're approaching to the fault, you will be having a little decrease of signal. Then when you are standing right above the fault, you will be having an increase. And then we do this way. We put one sensor right in front. We're putting the sensor away, like we're passing the damage. We're going right after it. And you can see that the signal is almost missing. So we have 80 something, 49 something, and we have passed the damage. So this is how it's done. And you can pinpoint the damage by moving back a little bit, by sticking the sensor. Also, I moved the sensor just, I don't know, 5 centimeters back, and the signal slightly increased, slightly, you see. And when I'm moving it completely back to the fault, which is here, we get maximum signal again. Easy as that. So if you move away the sensor, we just get no signal. It's easy as that. Yeah. So this is how you locate the cable fault with Aframe. And you can go all the way till the end of the cable. There will be no signal or slight signal or low signal. But right after the damage, the signal is almost completely missing. Yeah, let's get back to our table. So in this particular case, we had a cable which was laying on the ground surface, and that was an easy job. That's true. But if the cable is below ground surface, or if it's a pipe, metal pipe mostly, of course, you can do the same thing. But I would recommend increasing frequency to 8 kilohertz. Just try and see what happens. I guess you will have approximately the same result as we demonstrated to you today. So what's our advantages of this particular combination of equipment? First of all, when you're tracing, you can do both tracing a cable and also location of the faults. So you can do two jobs at once. That's very handy. Also, on the screen, you see the cable itself, the line of the cable, and you can see the graph with the signal. It's also very, very helpful. If you need to check the depth, you just switch the mode or remove the sensor, and depth measurement is becomes available, and you're able to measure the depth if you need that. But you will need that when you locate the fault eventually. Yes, and for this particular device works for 1 meter distance. This is a pinpointing device, which we have demonstrated to you. But you can use more for more distances, like 10 meters. You can use DODK sensor. This will require two persons, but it doesn't require any to stick anything into the ground. You connect this sensor to the receiver, and one person takes one conductor, another person takes the second conductor, and you go all the way the cable and test it the same way as I did with DKI sensor. But you can do this for 10 meters distance. So usually when we are giving the presentation of this equipment to our client, we state that this one is for pre-location. If you have two persons available, so they go all the way along cable and test it for faults. And when they find approximate range of the fault, something like 1 or 2 meters, they check it with A-frame sensor to pinpoint it and to repair it. I would say that this device is very handy in terms of installation fault testing. And moreover, we have another device here, which is used um, for more types of cable damages. First of all, is for multi-core cables. You can use this device uh, for location of intercore short circuit, like three-phase or two-phase short circuit. You can use this TDR 4.7. Also, this device can check if the cable is completely damaged, and my favorite feature of this device is that it can measure the distance to the fault. This one is my favorite. I love it because when you use this device with cable locator, first you check if there is any damage, and then you go all the way the cable with this device with cable locator, suppose AP19.3, and you check it and you locate the fault, and you feel really happy because you have done all the job by yourself. That's very valuable. It saves time and money, so you won't need many people to do this job. That's very very good for the business and for the saving time and money. Okay, we will do the following way. I will take this device with me to another end of the cable. You can see that there is another simulated damage right here. I will show you. This is here. In this junction box, we have simulated two cable damages. This one, we have simulated the short circuit and damage of the cable. I will show you. Just give me a second, please. I guess gloves won't help me here. Just let me. Yeah. See, this is one rod of the cable, and it's going nowhere, and it's going somewhere from here, so it's complete breakage. And here, when we have a duct tape, there is a intercore short circuit, and we will be testing both of these damages from the other side of the cable. Okay, while I'm going, you can ask any questions, and I will be trying to reply to them once we're done with the demonstration. Just hold on a second, I will take my phone. Wrong way. Happens. Okay, so we have another junction box on the other side of the cable. It is also marked with the color. Just let me turn off the simulation of the leaking of the current to the ground, and I will get back to you in a minute. Okay, I'm back. I'm back. Just give me a second, please. I'm back. Okay, first of all, we will try to locate the damage of the rods, inter-rod short circuit, or two-phase, three-phase short circuit. First thing we do is we turn on our device. Let's do it like this. We will wait for the software to load. Meanwhile, I will be connecting the cable. This is coax cable, and which I will be connecting to TDR port. As it's time domain reflectometer, I think that most of you know how does this thing works, and I will not be specifying the way it works, but I will explain why we're demonstrating this particular equipment all the time. First of all, this thing allows you to test the cables up to 256 kilometers. Can you imagine that? That's kind of powerful thing. Also, uh, it has USB port, and it supports multiple measurement and cable fault testing options, which can be used with the external GITA transmitter. Okay, let's move to the measurement, and we will see that there is another feature, brilliant feature of this device. Let me, I hope you can see. Uh, it's a color display. It's a color TFT display. I guess you can't see it because of the sun. Let me try doing it like this. Maybe it would be better like this. No, no. I guess not that great. But when we will see the damage, I will show you a little bit more. Okay, we will press F7, and on 30 meters distance, we can see that there is a damage, and this is the damage which we have simulated near our table. And when the graph is going down, it means that we have located the interface the short circuit between two conductors of the cable. And the cursor here, the yellow cursor here, indicates the distance between the connection point of the cable, which is here. You see that we connected crocodile clamps to the cable. And another cursor, cursor number 2, shows us the point where we have the fault. Actually, it's done like that. And the pulse is traveling through the cable and shows us, uh, and it is reflected back from the damage point, and that is how the speed is measured, and the distance also is measured. It's an easy formula from the school. Okay, what we do next is we will stop the measurement just to fix, to save the values on the screen. And now we will change the crocodile clamps. I will remove the safety caps. Just give me a second. We will set them to black and yellow green. We'll see what happens. I'm pressing start. You can see that the graph is going down uh, on the previous settings. But now I'm pressing F7 just to start measurement, and you can see that the same graph is going up. So there are some distortions. This is fine, but the main thing is the graph is going up. It means that we have located the the breakage of the cable on the same distance in the same small box which I showed you before. Also, we can change the scale, and we can see that somewhere our cable is going to end. This is the place. One of the conductors is going to end somewhere, and this is just distortions of the signal, but generally the main damage is here. Okay, what we can do with this, we can store it in the device's memory, and we can use it for further report. And also we can go to the menu, we can input settings, and we can upload this to USB flash drive or to memory card, and later use it for making a report on our personal computer. Also, this device has built-in accumulators, which it has charging port here, which is also used for charging, and this thing can work up to 30 hours of non-stop measurement with such big color display. I think this is kind of a big achievement. So I guess this is pretty much it. I'm turning off the device, disconnecting the wires, and now we're ready to have our question and answer session. My favorite part. Okay, let's take the equipment with us and go back to our table. So, if you have any questions, uh, I will be. I am here to answer. And meanwhile, we're going back to the table. I must say that TDR equipment can be used with any cable. We have multiple questions. What kind of voltage should be allowed to pass through the cable to use it with this TDR? Any voltage, because before using the TDR, we have to remove all the current and the voltage from the cable and test it when it's completely off. But it can be any kind of cable, 33 kilovolt, less or more, I don't know, 10 kilovolt, everything is fine for testing with TDR. Also, we have other models of TDR equipment which we are using for which we are developing and supplying to our clients. I hope that once we have in stock some of them, I will be able to show you. And some of you may know that we have a 3.3 TDR, the smaller one for 5-kilometer cables. And also we have something in the middle, like 30 kilometers, 128 kilometers cables. We have equipment for almost any application. Okay, I will check the comments and questions. What are the kind of kV rating for which this TDR can be used? I expected this question and I replied to it a couple of minutes ago. Any kV is acceptable for this particular device, so it's fine when it is completely off. For overhead cable, can it work? Yes, it can work for overhead cable, for low voltage cable, low current cable, telecom cable, except for optic fiber. This particular TDRs are used for power cables and metal cables, not for optic fiber. How long hours we can operate the AG105 with 8 batteries, just used for pipeline location? It depends on the settings. First of all, we state that it works approximately 10 to 15 hours Uh, Generally, you can set the transmitter to pulse mode to save the battery life, and also you can decrease its power, so you can extend it even up to 18 to 20 hours, but it depends strongly on the conditions of your location. If you are doing full power location, the battery will go off in 10 hours easily, all the batteries I mean. But if you are saving the power, if you are extending the battery life by using pulse mode or by adjusting the voltage level, you will get the better result. Can you show with your transmitter Gita? Unfortunately, we don't have demo unit for Gita because it's very expensive to keep this thing as demo unit. I hope that someday I will be able to push my management, my boss, to make a demo unit of this one of Gita, and we will be able uh, to show it to you in real conditions. I really hope so, but for now, unfortunately, we do not have that. Uh, your demo didn't need the search generator for this location. When do you need that then? That's a good question, Linda. And thank you for this question. Yes, in my presentation today, I didn't provide another method of cable fault location, which is called acoustic cable fault location. And Linda is asking, where is the surge generator which creates these electrical surges which can be heard by the acoustic sensor? First of all, in Russia, you just can't demonstrate high voltage surge transmitters on the parking lot because it's dangerous. When we do this job, we secure the area, we put the protective cones and signs everywhere when we're testing our test vents, our labs. We do this, but for the demonstration of cable fault, we do not do this. That's the first thing. That's the second thing. As surge transmitters or surge generators are very heavy and expensive, we do not supply them abroad. In Russia, we can find you any transmitter. We can manufacture this transmitter, no problem. But for our foreign clients, this equipment is very heavy and expensive. That is why we're not supplying these transmitters to external market yet. I hope that this year we will be able to supply some compromised solution, the compromise between costs and weight and dimensions, and you will be able to have your surge transmitter. But yes, there is an acoustic location, and basically this method is the same as water leak detection. You just listen with ground microphone, you just listen for the surge which is created by the transmitter, and in the spot of the surge there is an electric discharge, and you can hear it. It's easy as that. But yes, due to safety regulations, we're not doing this because we're doing it on our parking lot and we can't demonstrate it. And that's a really sad thing because we have to uh, demonstrate it somehow, and we have to supply this equipment to our clients somehow, but we can't demonstrate it due to uh, state and safety regulations. But thank you for a question. Yes, there is a way. Oh, of course, there is an acoustic location. But we supply acoustic fault locators without the transmitter, and we also supply them with our test vents. They are already included in the vents which were supplied. In the first path, can the path detected by the tool be recorded on a map previously stored in the memory of the equipment, or generate data to be used later and draw the path of the cable under the ground? If I understand your question right, You're asking if we can use previously stored data to locate the cable, and the answer is unfortunately no. This device is used only for the acquisition of data and storage of it in the memory, and later usage of it on personal computer. But if if you have a laptop or a tablet or something like that with you, you can upload the previously stored data to your laptop or tablet or phone, whatever it is. You can check it and compare with the device with device indications. And yes, you can store this information inside the device and later check it on your personal computer. And when you have stored the information inside the receiver, you can build track on the software which we are supplying with each device, and you can export it to save it in your local GIS software format. So you have options here. And the answer to the first question is no, you can't use pre-generated data, but you can use it on your phone or tablet or laptop, whatever it is. The answer to the second question is yes, you can store the data and build the tracks with the supplied software. Thanks for this grateful, gainful webinar and presentation. Thank you. Thank you very much. I really appreciate I really appreciate your participation, your questions, because personally I like giving presentations to our clients because we have a kind of communication here, and we can ask and answer questions. We can discuss the difference in the equipment and the features, and personally I like it very much. As a conclusion to our today's webinar demo, I would like to say that I'm always available in WhatsApp 24 by 7. You can find my number in tech support section of our website. You can check our contact section also on our website. You can send me an email to consult@technoac.com. Any technical or any commercial questions you can send directly to me. I will forward them to my colleagues, and we will reply to you as soon as possible. Also, we have Skype. We have private demos for our clients and for our dealers in Zoom, WhatsApp, Skype, anything. We're always available for communication and for demonstration and for providing all the information about our devices, because we are manufacturing them and we are developing them. So we are very sensitive to what people say about our equipment, and we have chance to improve this equipment in accordance with our clients' needs. So I thank you all for joining us today. I hope that we managed to boost the approach of spring a little bit by working outside on the fresh air and by stomping the snow today. Okay, thank you very much. Have a nice day. Stay safe, stay healthy, and I hope to see you on our next webinar in 2 weeks. Thank you very much. Bye bye.